This case study involved a steel potable water tank in Perry, Oklahoma. The tank was severely rusted, pitted with holes, and interior and exterior coating had failed miserably. It was rehabbed using Raven AquataFlex 506 on the interior and AquataPoxy 90 and Raven 545 on the exterior. Perry, Oklahoma is a small rural town with a population of 5,126. In June 2016, contractor WT Energy was contracted to recoat the entire exterior and interior of the town's water tank using products supplied by Raven Lining Systems. The most recent exterior and interior coating systems that had been applied roughly 7 years before was in very poor condition. The coatings used had most likely been a highly solvented epoxy coating applied at only 4 to 5 mils thick, with little to no surface preparation conducted before the coating was applied over the previous coating. This type of coating system had been applied to the tank several times over the years with very poor results. The exterior coating began to break down, crack, and peel off quickly with exposure to sunlight and the elements. Also, it is possible that too much solvent was added when the coating was applied, and being very thin with poor surface preparation resulted in a short coating service life. The interior coating was applied very poorly at an inconsistent thickness over little to no surface preparation right over the previous coating as well. This resulted in coating runs, blistering, rust, staining, chipping, and delaminations. There were many large pits on the interior surface and holes in the tank wall. The contractor WT Energy was contracted to recoat the entire exterior and interior of the tank using products supplied by Raven Lining Systems in June of 2016. The surface preparation on the outside of the tank was done by sweep blasting the surface to remove any loosely adhering coating, all rust spots down to a near white metal surface, and to provide a profile for the new coating system to bond to. On the interior of the tank, all the existing coating had to be removed by blasting with steel shot. Once this was completed, the surface was blasted again with abrasive to remove the surface profile, and then it was cleaned. The exterior coating application using a 15 to 20 mil coat of white high solids epoxy that was roll applied to the exterior of the tank after abrasive blasting to protect the tank from the corrosion. Then a single component UV stable aliphatic urethane was rolled applied 5 to 8 mils thick over the epoxy base coat to provide UV protection. Due to the pitted surface of the interior of the tank after abrasive blasting to a near white metal finish, a high-build Novolac hybrid polyurethane coating was chosen to provide longer-lasting protection. The Novolac hybrid polyurethane is NSF 61 certified for contact with potable water, cures to the touch in less than a minute, can be spray applied to more than 80 mils thick directly to the seal substrate once repaired, and has roughly 70% elongation to help prevent future cracking and impact damage. The cost to replace with a new tank was estimated at $500,000, not including demolition and site preparation. The cost to rehabilitate was $122,000, which included interior and exterior rehabilitation. The net savings was $378,000. Additional savings and benefits included stopped water losses due to leaks, improved water quality for the community, and it installed a higher performance plus 20-year life cycle design solvent-free flexible coating.